Now we're taking a look at operations on functions. We'll learn how to add, subtract, multiply, and divide two functions, and we will focus on the domain of the resulting function. Our essential question, we're again focusing on that function notation. This time we have two different ways to represent our function notation, so we'll need to be able to understand and apply both. Example 1, we're given an f function and a g function. And here we are told to add the functions together. I like this second notation better. It more explicitly tells you you're taking the f function and adding it to the g function with the variables. However, that first notation is in your book on your assignments, and I believe you'll see it on your tests as well. So it's important that you understand what that means. It is as well telling us to add our functions together and then gives us our input versus the function with the input at the same time. All right, so we're going to add our f function to our g function. Negative 7x squared cancels with positive 7x squared. 12x has no like terms, and 2 minus 5 is negative 3. When you're looking at the domain of a resulting function, you have to also consider the domain of the two original functions. In this case, we have functions where we're squaring x's, multiplying, and adding. You can do that to any number, so our resulting function has a domain of all real numbers. For part B, once we have the resulting f plus g function, instead of inputting x, this is telling us to input 2. So we'll replace the x in our resulting function with 2 instead, and then simplify. 12 times 2 is 24, minus 3 is 21. And finally, we will subtract our functions. Starting with the f function and subtracting off the g function, we have negative 7x squared plus 12x plus 2 minus our g function of 7x squared minus 5. Before we combine our like terms, we want to distribute that negative sign so we don't lose track of it. Negative 7x squared plus negative 7x squared is negative 14x squared. Our 12x still doesn't have like terms, and that 2 plus 5 gives us a plus 7. Again, looking at the domain of our resulting function, we can square any number, multiply any number, and add or subtract any numbers together, so we have all real numbers for this domain. Now we're going to look at multiplying and dividing functions. Again, the two different types of notations, either multiply the functions together and then giving you the input of x, or take f function and multiply it by the g function with the input attached to each function. I like that second notation better. It explicitly tells you take your f function, 3x squared plus 1, and multiply it by your g function, 5x minus 2. In order to simplify this, we'll need to FOIL. 3x squared times 5x gives us 15x cubed. 3x squared times negative 2 is negative 6x squared. 1 times 5x, and 1 times negative 2. In this case, we have no like terms to combine, so our function is simplified. Domain, again, we have no denominator to look at restrictions. We have nothing under a radical, so we have all real numbers for our domain on this one. Part B, looking at the f times g function evaluated at 3, tells us to replace every x in our expression with a 3. 15 times 3 cubed minus 6 times 3 squared plus 5 times 3 minus 2, which gives us a total of 364. Part C, we are dividing our functions. Our f function is 3x squared plus 1 divided by our g function of 5x minus 2. The numerator of our function cannot be factored. neither can the denominator, so our answer is in simplest form. To find our domain restriction, we do have a denominator. Division by 0 is undefined, so we set that denominator not equal to 0, adding 2 to both sides, and dividing by 5 gives us a domain restriction of 2/5. So x can equal all real numbers except 2/5. The last piece, understanding this function notation, this says take the f times g function evaluated at 5. So everywhere there's an x in the answer to part A, which was our multiplication function, we will replace it with 5 instead, and then add just the f function evaluated at 4. Looking back at part A, substituting all of those x's with a 5 instead, we have 15 times 5 cubed minus 6 times 5 squared plus 5 times 5 minus 2. Then we will add our f function evaluated at 4. As a reminder, our f function is 3x squared plus 1. We will replace that x with 4 and add it on to the end of our multiplication function, which gives us a result of 1,797. You have 3 U-Try questions. Determine the result of the operation as well as the domain.